So good morning. Exercise 7.5, very important concept in integration chapter. So partial fractions. So now we move on to the introduction to partial fractions, because with the real life I'll connect this concept with the real life. Okay, because this is a season which we guys will be seeing the IPL match. Okay, so I'll connect with the IPL match. Whenever I teach a partial fractions, I'll connect this one with the IPL, any team, CSK, Mumbai Indians, whatever it is, whatever the mind is coming, I'll keep a name for this one. So there are 5 concepts in your textbook, page number 317, partial fractions. So I've given you already all the concepts and all. Now we have to move on to the 5 concepts. Introduction to partial fractions, PF, introduction to partial fractions. There are 5 concepts. First concept: if any integration with the denominator, there are 2 brackets. For example, x plus a. I'll give next video. I'll put the sums. Then you'll get. I'll give you some example also. If any fraction with the integration with the denominator 2 brackets, then we have to use the. I'll take, because I will take a CSK. Okay, Chennai Super Kings. So CSK. So what is CSK? If any integration with the 2 brackets in the denominator, I will use the CSK2 method. So what is the CSK2? Because 2 bracket na CSK2. So A upon constant first bracket and B upon second bracket. I will divide into 2 pieces. A upon first bracket plus B upon second bracket. When I have to use CSK2. CSK2 now what's the meaning? Denominator 2 brackets. And numerator, so you can see your textbook page number 317. 317 you can see. Okay, later I'll come back to the numerator. If any fraction with the denominator 3 brackets, x plus a, x plus b, x plus c. Okay, we have to use CSK3. What is CSK3? 3 brackets. So I kept the name as CSK3. So what I have to use? So A upon first bracket, B upon second bracket, and C upon third bracket. So CSK2 na 2 bracket, CSK3 na 3 bracket. You can ask me, sir, suppose it was 4 brackets comes, so what I will do? CSK4. But I'm not keeping 4 brackets. They won't ask you mostly. But you imagine, if it 4 brackets comes na, A upon, B upon, C upon, D upon. Okay. So 2, I repeat again. If any integration with the 2 brackets, denominator is CSK2. So A upon, B upon. If any integration with the 3 brackets, A upon, B upon, C upon, 3 brackets. Okay, so the five methods, right? So I have taken CSK2, CSK3 alone, because it's linked with 2 brackets, not 2, 3 brackets, not 3. Now third one, I will come back later about the numerator is also very important. Wait, now CSK, now CSK1. CSK1 is if any integration with the denominator whole square, not the single, not the x square, so whole square. This is said to be CSK1. What I have to do with the CSK1? Whole square na, the concept is A upon x minus a and B upon x minus a the whole square. I repeat, if any integration with the denominator whole square na, A upon the single term plus B upon the entire term should come there. This is CSK1. CSK1 na whole square. CSK2 na 2 bracket. CSK3 na 3 bracket. Okay. And partial fractions with the 4th type. Any integration with a fraction, they are given you whole square C. Okay. So whole square with the attachment x minus a with the attachment. Okay, whole square with the attachment. This is said to be CSK2, 3 already gone. Now I will take CSK4. So CSK4 na whole square with the attachment. So what I have to do? So A upon whole square. Now whole square, now what you will do? A upon the single term, right? So A upon x minus a, B upon the whole square. So like same thing I have written here, plus C upon the attachment. Attachment, what is the attachment? X minus B. I repeat again, CSK4 whole square with the attachment. So whole square, what I will do? A upon x minus a plus B upon x minus a the whole square. Similarly, A upon x minus a plus B upon x minus a whole square. I have completed. Attachment comes, so I written C upon x minus B. Okay, and the 5th method, It's not a whole square. CSK5, it is inside, they'll give you the square. So CSK5, I'll write here. CSK5, I'll write separately. So CSK5 is any integration, they will give you the inside the whole square, x square plus bx plus c times x minus a. Single term comes, keep it separately. Or they will give you the bracket in front of x minus a also, they will give you. Don't worry about that. So what I will do, this is what I kept for CSK5. CSK5 in a single bracket. Okay, so a upon x minus a plus bx plus c upon the entire quadratic, x square plus bx plus c. Okay, CSK5 is single bracket and bracket kulla square. There is a difference. Whole square, but inga inside square. Inside square vanda bx plus c, x square plus bx plus c. Am I clear? I repeat one more time. Partial fractions. What's the partial fractions? Any integration with the fractions. Okay, name is the fraction, partial fractions only. So all the integration will be as in the fractions. Numerator will come back to later. Wait. If any fraction contains two brackets, CSK2, so a upon b upon. Any fraction with the three brackets, CSK3, a by b by c by. Any fraction with the whole square, a by x minus a plus b by x minus a the whole square, CSK1. And fourth, CSK, this is CSK4. Okay. So otherwise I'll go for CSK3, 4, 5 also I can go. Okay, why I have to confuse yourself? Okay, so CSK1, there's 5 fractions. So 2, 3, 4, 5, 6. Okay, CSK1 na whole square na a by given. And CSK4 na whole square into single term. So whole square another a by x minus a, b by x minus a the whole square, single term na c by. And the last one upon, that is any numerator. Wait, I'll tell you. X minus a single term and inside square. I repeat the word inside square. So a upon x minus a plus bx plus c upon this bracket, bx plus c upon the quadratic polynomial. So they are given you in your textbook or exercises, separate exercises. So exercise 7.5, 23 sums. Okay, so let me solve the 23 sums. I'll give you a small hint, and now I move on to the fully formulas only, which you have already done. All things are formulas you have already done. Okay, I'll go very slowly. I'll give you some examples, exercise. I'll do. Any doubt? CSK1 first step, CSK2, CSK3, CSK1, CSK4, CSK5. Now come back to the numerator. Numerator first one CSK2 na, that will have x square or a coefficient 1 agano. CSK2 na, that is CSK2 completed. CSK3 na, and the polynomial numerator la x or a coefficient square agano. And CSK1 whole square apo linear polynomial x square x power 1 agano. Mostly don't worry about my suggestion is, they don't worry, they will give you one of few sums only. You have to check the numerator. Okay, numerator power 2 on the then only you have to use. So don't worry, once you start to practice, now sure you'll get an idea. So which one CSK1 or 2 which one you have to use. So px square plus qx plus r, and the fifth one again px square, numerator px square plus qx plus r. See here, quadratic polynomial. Whenever you are exceeding two brackets, exceeding more than 2 brackets now, power is coming. So see, 2 exceeding more than 2, you'll get 2. Okay, but whole square, and this is x. See here, both the things you can compare. So I'll finish it up. This is the introduction to the partial fractions. So whenever 2 brackets, CSK2. Whenever 3 brackets, CSK3. Whole square, x minus a the whole square, and CSK1. Whole square with the attachment. Okay, with the attachment, like a small dish. Okay, like a rasam, sambar, like you can use a whole square with the attachment. Now is CSK4. And then a single term inside square. There is no whole square, inside square. Now CSK5 for that, a upon single bracket bx plus c upon this one. If they given one more quadratic polynomial, now it will become bx plus c, right? The next one will become dx plus e upon x square. Like this it will goes on extend. Once you do the textbook on R.D. Sharma, you'll get the exemplar book. You'll get many ideas. Okay, for everything there is a shortcut. Okay, I'll come back to you. So thanks a lot. I'll move on to the, I'll go to the next, I'll go to the exercise in the next video. I hope so you are clear. Keep a small name. You can keep as, you can, that's your wish. I have to keep in your mind, I keep a name. So now I'll close the eyes. I'll give you. What is it? CSK2 na, how many brackets will be there in the denominator? 2 brackets. CSK3 na, you will have 3 brackets. CSK1 na, whole square. CSK4 na, whole square with the single bracket. CSK5 na, single term with inside the bracket. Like this, you have to keep on, you have to keep on revising yourself. Then it will be very easy for you. And one more concept I wish to tell you here. In the previous exercises, if the numerator and denominator power, x oda power same irundalo, illa numerator power perusa irundalo, long division method. Kindly refer my previous video. If the numerator is power is smaller than denominator, na, it's a clear. You have to use a lambda mu method, which I have done many sums. Lambda mu method. So please be very clear. Lambda mu method. But for using the long division method, you have to be small, that is quotient plus remainder by denominator. That also I have done in the previous video, which will be used in the partial fractions also. Go through the previous video, find out what is completing square method, what is lambda mu method, what is long division method. These three you have to be very thorough in integrations. Thanks a lot. I'll put one more video that is fully sums based on partial fractions. In that I won't revise the CS. Just by seeing the question itself, we can tell you that which is CSK 1, 2, 3, everything. Okay. For example, now itself we can finish it up that in the exercises which is CSK 1, which is CSK 2. That also we can finish it off. Then I'll move on to the sum. Okay. So with the introduction, I can tell you what are the CSK, which sum. I'll put the question number, finish it off. So let me put the question number, then it will be easy for you. Now example number 11, 12, 13, 14, 15, 16, then exercise 7.5. Exercise 7.5, so there are 24 sums. I'll put now itself. I'll tell you which CSK, which number. 1, 2, 1, 2, 3, 4, 5, 6. For all the 23 sums, we can finish it off. Okay, so now move on. You have to find out which CSK 1, 2, 3, 4, 5. Which one you have to find out. Now example number 1, page number. Example number 1, page number 318. Example number 1, denominator 2 brackets. Denominator 2 brackets na, it is CSK 2. And question number 12, denominator again. Question number 12, numerator x oda power, denominator x oda power same irukku. So same irundave which method I have to use? I told you to do the long division method. Quotient plus remainder by denominator. Then you can apply which method? This again here it will become CSK2. Then 13 sum. Whole square and a single term. Whole square and a single term na CSK4. And denominator 2 brackets CSK2. Example number 15. Denominator single whole square. Single whole square na CSK1. 16th sum. Whole inside square. So CSK5. Next. Exercise, first exercise. Denominator 2 brackets. So CSK2. Second one, x plus 3, x minus 3. 2 brackets. CSK2. 3 brackets. 3 brackets. The only thing is numerator you have to get x square, right? Okay, let me do CSK3. 4. Again 3 brackets. CSK3. Fifth sum. If I think you can, you have to do the lambda mu method. I think so, because fifth sum, the numerator power is smaller than the denominator power. If it's possible to do the factorize, x square plus 3x plus 2. If it's possible to do the factorize, is CSK2. If it's not able to factorize, you can use a lambda mu method. We'll see. Then I'll move on to the sixth sum. If you multiply x inside, it will become long. Both the numerator and denominator power same. Same now what I have to do? Long division method. Then only CSK you have to find out. Sixth sum. Inside square. Upper CSK. Sixth sum I have already completed. I have written wrongly. Fifth sum you have to do. Let me check. Fifth sum is lambda mu method. Which one you have to check? Sixth sum is, I already told you that, long division method, because both x numerator and denominator are same. Seventh sum, inside square, and then inside square now it is CSK5. Let me do. And eighth sum, whole square in a single term, CSK4 whole square in a single term. And ninth sum, I think you'll get 3 brackets if we factorize. So I think CSK3, 3 brackets and CSK3. 10th one, inside square, x plus 1, you can it is x plus 1, x minus 1. It will become again 3 brackets. So I think CSK3 you can do 3 brackets, or you can go for another method also. 11th sum, again it will become 3 brackets, x plus 2, x minus 2, CSK3. You can do 3 brackets, or see these 2 sums, no, you can do by CSK3. If any number, if all the numbers have become 0 now, then you have to go by some other method. Inside square now, it may, for this 10 and 11, CSK5 also will suitable, because you have to take the numerator. In the numerator, CSK inside square now, page number 317 la, CSK5 ke numerator la, it must be px square, but for 10 and 11 it's not px square. So you have to be very careful in 10 and 7. And 11th sum I given. 12th one numerator's power is bigger, so again you have to go for long division method. 13th one, inside square, so again inside square na, CSK5. 13th one it may be CSK5. And 14th one, whole square single, upper CSK1. 15th sum, x square plus 1, x square minus 1, you have to put x square as a t. Its 15th sum is based on example number 14. Example number 14. 15th sum is based on example number 14. So any guys, if you know the 14th example, then only you are able to do the 15th sum. Then 16th sum is a common, no point leave it. 17th sum you get single term, I think so. So you'll get CSK 2 brackets. 18th sum is based on again example number 14. And 19th sum, example number 14. See, there are 3 sums based on example number 14. And 20th sum, x square minus 1, x square, again it's example number 14, I think so. You have to refer. And 21, you have to put, I think you'll get 2 brackets, check. 22, CSK2, 21, and 23, inside square and single term is CSK5. So now we'll do all the sums. Refer to the next video to get an idea. You can and you will.